Space hides more secrets than we can possibly conceive. You are about to journey through 25 of the most baffling objects ever found in the cosmos. We will uncover mysterious signals that have never been repeated and cosmic structures so strange they challenge our understanding of physics itself. This tour of the universe's greatest wonders will reveal just how bizarre reality can be. What is the one cosmic mystery you hope has a logical explanation? On a quiet August evening in 1977, a radio telescope in Ohio known as the Big Ear was silently scanning the sky. It was performing a routine survey of the cosmos, listening for the faint whispers of radio waves that naturally emanate from space. Then, something extraordinary happened. For 72 seconds, the telescope recorded a signal so powerful and so unusual that it defied all conventional explanation. The signal was a narrowband radio burst, meaning it was concentrated on one specific frequency, the frequency of hydrogen, which many scientists consider a logical channel for interstellar communication. When astronomer Jerry Amon reviewed the computer printout days later, he was so stunned by the sheer intensity of the reading that he circled the alphanumeric sequence in red pen and wrote one word beside it: wow. That sequence, 6EQUJ5, represented a signal that jumped to 30 times the strength of the background noise and then vanished, never to be heard again. This single event ignited a firestorm of debate that continues to this day. Was it a momentary glitch, a passing satellite, or a natural celestial event we simply do not understand? Or was it something else entirely, a fleeting message from an intelligence far beyond our own, a cosmic hello that came and went before we could even think to reply? The original printout with that iconic red circle remains one of the most tantalizing pieces of evidence in the search for cosmic company, a mystery etched on paper that challenges our place in the universe. While the wow signal was a singular event, another cosmic mystery has proven itself through relentless repetition. Far away in the constellation Cygnus lies a star called KIC 8462852, but you probably know it as Tabby star. This seemingly ordinary star behaves in a way that no other star we have ever seen does. Its light does not pulse with a steady rhythm. Instead, it flickers and fades in chaotic, dramatic plunges. Imagine a 100-watt light bulb in a distant room, and without warning, it dims to the brightness of a 78-watt bulb. Then later, it plummets all the way down to the glow of a mere 22-watt bulb. This is not a slight dip, it is a staggering 22% drop in luminosity, as if something colossal is moving in front of the star, blocking its light in a way that defies all known patterns. The discovery of this bizarre behavior did not come from a team of professional astronomers in a control room. It was citizen scientists, volunteers sifting through public data from NASA's Kepler telescope as part of the Planet Hunters project, who first raised the alarm. They flagged the star as not just unusual but profoundly weird. The data showed not the clean, symmetrical dip of an orbiting planet, but a jagged, unpredictable light curve with no discernible rhythm. This kicked off a frantic search for an explanation. Theories erupted across the scientific community. The initial, more conservative idea involved a massive swarm of comets, thousands or even millions of them, encircling the star in a chaotic orbit. Such a swarm could, in theory, block irregular chunks of light, yet the sheer scale required to cause such deep dimming events pushes the limits of plausibility. This led to a far more sensational and admittedly thrilling hypothesis. Could we be witnessing the construction of an alien megastructure? The concept of a Dyson sphere, a colossal shell or swarm of energy-collecting platforms built by an advanced civilization to harness the entire power output of its sun, would perfectly explain the massive, irregular blocks of starlight. It is a breathtaking thought that we might be seeing the shadows of a project on a scale beyond human comprehension, but science demands evidence, not just wonder. Continued monitoring has shown that Tabby star continues to dim in new and unpredictable ways, frustrating any single simple explanation. The truth is, the most likely answer is a natural one, perhaps a vast warped disk of dust and debris from a shattered planet or a family of enormous fractured moons. Yet the alien megastructure idea endures because it so elegantly fits the baffling observations. It remains the ghost in the machine of astronomical data, a tantalizing possibility that we have not yet been able to completely rule out. This star forces us to confront the limits of our knowledge, challenging us to find a new kind of physics or to accept that we are not alone. Just a few years ago, our solar system received its first confirmed visitor from the vast space between the stars. In October 2017, the Pan-STARRS telescope in Hawaii spotted a faint point of light moving at incredible speed, an object we now call Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. Its trajectory was unlike anything we had ever seen, a hyperbolic path that proved it was not bound by the sun's gravity and was merely passing through our neighborhood. As astronomers scrambled to observe it, they uncovered one mystery after another. Its shape was the first shock. Based on the way its brightness changed dramatically as it tumbled through space, scientists deduced it was not a typical roundish asteroid or comet. It was profoundly elongated, perhaps 10 times longer than it was wide, resembling a cosmic pancake or a cigar tumbling end over end. This was a form never before seen in our solar system. Then came the real puzzle, its acceleration. As Oumuamua sped away from the sun, it did not follow a purely gravitational path. Something was giving it an extra push. For a normal comet, this is easily explained by outgassing, the sun's heat vaporizing ice on its surface and creating jets of gas that act like a gentle rocket engine. But when telescopes pointed at Oumuamua, they saw no coma, no tail, no dusty envelope or any sign of outgassing whatsoever. It was completely dark and inert, a silent, speeding rock that was somehow accelerating without any visible means of propulsion. This non-gravitational acceleration sent scientists into a frenzy of theorizing. The leading natural explanation suggests Oumuamua could be a fragment of a Pluto-like planet from another star system, a chunk of solid nitrogen ice. As the sun warmed it, this nitrogen could have sublimated directly from solid to gas, providing the invisible thrust without creating a visible, dusty tail. It is a compelling idea, yet it requires a very specific and somewhat unlikely series of events to create such a pure, sturdy shard. The absence of any visible outgassing, however, opened the door for a much more provocative idea. Could Oumuamua be artificial? The esteemed astronomer Avi Loeb famously proposed it might be a light sail, a piece of advanced technology from an extraterrestrial civilization. A light sail is a thin, reflective sheet that uses the pressure of starlight for propulsion, much like a boat sail uses wind. This would perfectly explain its unusual flat shape and its mysterious acceleration without a visible coma. While most of the scientific community leans toward a natural origin, the light sail hypothesis persists because it so neatly solves the riddle. Oumuamua was a fleeting guest, a cosmic postcard we barely had time to read before it vanished back into the interstellar dark. It left behind more questions than answers, a silent, tumbling enigma that forces us to wonder what other strange travelers are drifting, unseen, through the emptiness between the stars. While Oumuamua was a visitor from another star system, a far older mystery is said to orbit our own planet. For decades, stories have circulated about the Black Knight satellite, an alleged alien object that has been circling Earth for 13,000 years. The legend paints a picture of a dark, silent sentinel of extraterrestrial origin watching us from the void. The most famous piece of evidence is a single grainy photograph from the 1990 Space Shuttle mission, showing a strange, angular black shape against the curvature of the Earth. It looks undeniably artificial and utterly mysterious, but what is the truth behind this compelling cosmic myth? The reality, while less sensational, is a fascinating lesson in how easily we can misinterpret what we see in space. That iconic photograph, it turns out, is almost certainly a thermal blanket. Astronauts on a spacewalk from the shuttle Endeavour lost the blanket while testing repair techniques. It was a piece of human technology, briefly orbiting our planet before falling back to burn up in the atmosphere. This simple explanation deflates the core of the legend, but it does not explain how the story began. The origins of the Black Knight are a tangled web of misidentification. In the late 19th century, the pioneering inventor Nikola Tesla reported receiving strange, repeating radio signals that he thought might be of intelligent origin. Decades later, in the 1920s, amateur radio operators began picking up what they called long-delayed echoes, where their own signals would bounce back to them seconds later than expected. Some speculated these echoes were being reflected by an unknown object in orbit. Then in 1960, the United States Department of Defense announced it was tracking a dark, mysterious object in polar orbit. The public imagination ran wild, but the object was soon identified as the broken-off casing from a United States Air Force satellite program, a piece of human-made space junk. So why does the Black Knight myth endure so powerfully in books, documentaries, and online forums? It taps into a deep and universal human desire for connection, for proof that we are not alone and that our history is far more exciting than it appears. The idea of an ancient artifact, a relic from a forgotten cosmic civilization, is a story we desperately want to be true. It transforms the cold, empty space around our world into a place of ancient mystery and potential discovery. Yet, despite decades of searching, there is not a single piece of credible scientific evidence for its existence. No consistent radar track, no verified photographs beyond that lost blanket, and no signals that cannot be explained by natural phenomena or human activity. The Black Knight is a phantom, a ghost story we tell about the sky above us, a reminder that sometimes the most compelling mysteries are not out there in the dark, but within our own boundless capacity for wonder and imagination. The Phantom Satellite is a story we tell ourselves, but the force pulling our entire galaxy is a reality we cannot ignore. Far beyond the familiar stars of the Milky Way, in the depths of intergalactic space, a cosmic tug-of-war is underway. Our galaxy, along with every other galaxy in our local neighborhood, is being drawn toward a specific point in the constellation Centaurus. Astronomers call this incomprehensible force the Great Attractor, a gravitational anomaly of staggering power. It is the ultimate unseen hand, pulling thousands of galaxies, including our own, through the void at a breathtaking speed of over 14 million miles per hour. We are not moving randomly. We are all flowing on a river of space-time toward a destination we cannot yet see. The central mystery of the Great Attractor is that it lies hidden in plain sight, located in a region of the sky known as the zone of avoidance. This is not a forbidden area of space, but a visual blind spot created by our own galaxy. The plane of the Milky Way is thick with cosmic dust and billions of stars, creating a brilliant but obscuring wall that blocks our view of the universe beyond. Trying to see the Great Attractor from Earth is like trying to spot a distant lighthouse from the bottom of a murky, turbulent ocean. For decades, this cosmic curtain prevented us from understanding what was pulling us. What could possibly possess the gravitational might to command the motion of entire galaxies? The leading theory suggests the Great Attractor is not a single, monstrous object, but an immense concentration of mass, a gravitational core of a region we now call the Laniakea supercluster. Laniakea, a Hawaiian word meaning immense heaven, is a cosmic filament, a vast web of hundreds of thousands of galaxies, all bound together by gravity. Our own Milky Way is merely a suburban outpost on the edge of this colossal structure. The Great Attractor is likely the supercluster's central density peak, a place where the pull of countless galaxies and, more importantly, an enormous halo of dark matter creates a deep gravitational well. This invisible dark matter, which makes up most of the universe's mass, is the true engine behind the pull. Visualize a map of the cosmos not with stars, but with galaxies as points of light, all streaming like leaves on a river, converging toward a single, powerful vortex. To peer through the zone of avoidance, astronomers have turned to telescopes that see in infrared and radio wavelengths. These instruments can cut through the obscuring dust, much like a pair of night vision goggles lets you see through fog. These surveys have revealed that the core of the Great Attractor is an immense cluster of galaxies, but its mass still does not fully account for the violent pull we feel. This suggests an even larger structure, perhaps the entirety of the Laniakea supercluster, is doing the pulling. The Great Attractor, then, is not a final destination, but a waypoint. Our galactic journey does not end there. An even greater mass, known as the Shapley Attractor, lies beyond it, pulling the Great Attractor itself. We are caught in a cosmic chain of gravity, a reminder that in an expanding universe, the largest structures are still collapsing, drawing everything together in a slow, inexorable dance that will last for billions of years. Gravity's immense pull shapes the cosmos, but some structures seem to defy its ordinary rules. Drifting through the constellation, Serpens is a galaxy so perfectly formed it appears almost artificial. This is Hoag's object, a cosmic eye staring back at us from 600 million light-years away. At its heart lies a dense, brilliant core of ancient yellow stars, glowing like a stellar retirement community. Surrounding this core is a stunning, nearly flawless circle of vibrant blue stars, a ring so symmetrical it looks like a celestial smoke ring or a giant's engagement band tossed into the void. The most baffling part is the profound, dark gap between the two. A chasm of apparent nothingness separates the golden core from the youthful blue ring, creating a clean, circular divide that challenges our understanding of how galaxies evolve. How does such a perfect structure come to exist? The most widely accepted theory points to a violent, ancient collision. Billions of years ago, a smaller galaxy might have plunged straight through the heart of a larger, disc-shaped galaxy. This cosmic pulse would have sent ripples of density through the galaxy's gas, triggering a wave of star formation in a perfect circle, much like a stone dropped in a pond creates expanding rings. The original galaxy's core would have remained mostly intact, while the disruptive event stripped away or triggered star formation in the outer regions, leaving the dark gap we see today. Another compelling idea suggests this is an extreme example of a resonance ring. In this scenario, a central bar of stars, which has since dissolved, created a gravitational resonance. Think of it like pushing a child on a swing at just the right rhythm to build momentum. This resonance would have shepherded gas and dust into specific stable orbits, funneling material into that precise circular ring where new blue stars could ignite. High-resolution images from the Hubble Space Telescope reveal the object in breathtaking detail, showcasing the sharp divide and the countless young, hot stars blazing in the blue ring. These stars are cosmic infants, burning fiercely and destined for short, brilliant lives. Animations illustrating the galactic collision hypothesis show a smaller intruder galaxy screaming through a disk, the resulting gravitational shockwaves compressing gas clouds and lighting the ring of fire we observe today. The resonance model animations depict a more graceful, rhythmic process, with invisible gravitational forces orchestrating the cosmic material into a perfect circle over eons. Hoag's object stands as a serene mystery, a beautiful exception to the typical spiral or elliptical forms that fill the universe. It is a reminder that the cosmos has a flair for the artistic, crafting perfect rings in the darkness where we would least expect to find them. The serene perfection of Hoag's object gives way to a structure that seems drawn with a cosmic ruler. Drifting 2,300 light-years away in the constellation Monoceros, the red Rectangle Nebula lives up to its name, appearing from our vantage point as a series of glowing, concentric red boxes, a celestial ladder reaching into the dark. This stunning geometry is not a sign of alien engineering, but the spectacular death throes of a star much like our own sun. At the system's heart lies a binary pair, two stars locked in a tight orbital dance. As one of them exhausted its nuclear fuel and began to die, it swelled into a red giant, shedding its outer layers into space. The gravitational influence of its companion star then funneled this expelled gas into two opposing cones, creating what astronomers call a bipolar nebula. The result is a beautiful hourglass shape, but our view from the side makes it appear as a rectangle. The extraordinary sharpness, the precise X shape that gives it the rungs of a ladder, comes from an unexpected source. Thick, dense rings of dust, possibly ejected by the stars during an earlier phase, act like a cosmic corset. They pinch the outflowing gas at the waist, constricting it and forcing it to expand more at the poles, which sculpts the gas into those remarkably straight, angular walls. The vibrant red color itself is a clue to a deeper mystery. This nebula is a cosmic factory for complex organic molecules. Spectroscopic analysis has revealed the presence of polycyclic aromatic hydrocarbons, or PA. These are large, stable molecules made of interconnected rings of carbon and hydrogen atoms, essentially the basic building blocks of soot. On Earth, similar molecules are found in charcoal and in the exhaust from a car engine. Finding them here in the cold depths of space is profound. It tells us that the fundamental chemical ingredients for life are not unique to planets, but are forged in the nuclear furnaces of dying stars and scattered across the galaxy. Detailed imagery from the Hubble Space Telescope reveals the nebula in all its intricate glory, the nested rectangles glowing with a deep crimson light against the black velvet of space. Three-dimensional models show the true hourglass shape of the bipolar outflow, with the central dust rings clearly visible, constricting the flow like a hand squeezing a tube of paint. Graphics can highlight the molecular structures of these pHs, showing their elegant, ring-like forms, the very seeds of complexity floating in a stellar graveyard. The red rectangle is more than a beautiful oddity. It is a chemical laboratory on a galactic scale, demonstrating that the universe is not only stranger than we imagine, but far more connected, seeding the cosmos with the very stuff from which worlds and perhaps life itself can one day arise. From the molecular seeds of a dying star, we leap to a mystery of pure invisible energy. In 2019, astronomers mapping the sky with a powerful radio telescope called ASCAP in Australia stumbled upon something that should not exist. They found perfect ghostly circles of radio emission floating in the deep field like cosmic smoke rings. These are the odd radio circles, or ORC, and they are utterly baffling. They are so faint and so vast that they were only discovered with the latest generation of radio telescopes, hidden in plain sight for eons. The sheer scale of a single ORC is difficult to grasp. Each one is about 1 million light years across. To put that in perspective, it would take a beam of light traveling at the universe's ultimate speed limit an entire 1,000,000 years to go from one side of the circle to the other. Our entire Milky Way galaxy will be a mere speck inside one of these colossal rings. They exist in the lonely space between galaxies, far from the bright lights of galactic centers, which makes their origin even more puzzling. What cosmic event could possibly create such immense, perfectly circular structures, and why do they only reveal themselves in radio waves, remaining completely invisible to optical, infrared, and X-ray telescopes? The leading theories are as dramatic as the objects themselves. One compelling idea is that these rings are the aftermath of a truly gargantuan explosion. Imagine two supermassive black holes at the hearts of merging galaxies, slowly spiraling together over billions of years until they finally collide. The resulting merger would unleash a tsunami of gravitational waves, a shockwave of energy so powerful it could rip through intergalactic space, creating a spherical blast wave that we see as a circular ring from our vantage point. Another hypothesis points to a phenomenon called a starburst galaxy, a galaxy undergoing a ferocious burst of star formation. This creates countless supernovae exploding in rapid succession, driving a galactic wind of particles and magnetic fields that blows out into the void. If this wind punches into a thin, surrounding layer of intergalactic gas, it could create a perfect expanding shock front, a colossal bubble that glows in radio frequencies. Radio telescope images reveal these ORCs as ethereal, glowing halos, perfect circles of faint light against a dark background. Artistic interpretations of the black hole merger theory show a titanic, spherical explosion blossoming in the void, a silent, slow-motion fireball on an unimaginable scale. Visuals for the starburst hypothesis depict a brilliant, chaotic galaxy at the center, spewing a hurricane of stellar winds that inflate a perfect, shimmering bubble around it. The true nature of the odd radio circles remains one of the most active puzzles in modern astronomy. They are a stark reminder that our universe is still full of surprises, that even with our most advanced tools, we are only just beginning to see the outlines of the giants moving in the cosmic dark. Most galaxies are dynamic, ever-changing cities of stars, but one ancient giant has remained frozen in time. NGC 1277 is a cosmic fossil, a relic from the universe's violent youth that has not changed in over 10 billion years. While our own Milky Way continuously forges new stars from clouds of gas and dust, this colossal galaxy stopped all star formation when the universe was just a toddler. It is a snapshot of an earlier cosmic era, a place where billions of ancient red stars glow with the steady light of extreme old age, with no brilliant blue newborns to break the monotony. This alone makes it a profound oddity, but its real mystery runs far deeper, challenging a fundamental pillar of astronomy. This galaxy appears to have no dark matter. Dark matter is the invisible, mysterious substance that makes up the bulk of a galaxy's mass. Its gravitational pull is the glue that holds galaxies together, the unseen hand that keeps stars from flying apart into the void. Finding a galaxy without it is like finding a vast, spinning carousel with no central pole, a structure that by all rights should have torn itself apart eons ago. The discovery sent shockwaves through the scientific community. How could something so massive exist without the cosmic scaffolding we thought was essential? The leading theory paints a dramatic picture of the early universe. NGC 1277 resides in the dense heart of the Perseus galaxy cluster, a crowded metropolitan area of the cosmos. Astronomers speculate that in this frenzied environment, the galaxy may have formed through a different, more violent process. Instead of slowly coalescing from a cloud dominated by dark matter, it could have been born from the direct collision of immense streams of primordial gas. In this high-density region, the sheer pull of ordinary matter may have been enough to jumpstart its formation, bypassing the need for a dark matter framework entirely. Imagine a bustling city built so densely that its own structure support it, with no need for a bedrock foundation. Visuals comparing NGC 1277 to a typical spiral galaxy like the Milky Way are striking. One shows a serene, starry pinwheel, alive with blue stellar nurseries, while the other is a dense, featureless red ellipsoid, a stagnant pool of ancient suns. Simulations of these early universe conditions depict a chaotic, crowded space with torrents of raw gas smashing together to form massive, dark matter-free galaxies in a frantic burst of creation. Graphics explaining the role of dark matter would show a typical galaxy enveloped in a vast invisible halo, its stars orbiting within this gravitational grip, while an image of NGC 1277 would stand alone, its stars bound only to each other, a cosmic island defying the rules. This relic galaxy forces us to reconsider the very recipe for building a universe, proving that the cosmos has more than one way to construct a giant. While the universe seems endlessly crowded, some corners are defined by a profound and terrifying emptiness. Drifting through the constellation of Boötes lies a region so vast and so barren it has earned the name the Great Nothing, a cosmic desert spanning an almost incomprehensible 250 million light-years. If you placed our Milky Way at its center, the nearest edge of this void would be a journey of over 100 million light-years in every direction. Within this staggering volume of space, astronomers have found only a handful of isolated galaxies, perhaps 60 in total, where the standard models of the universe predict there should be thousands. It is a hole in the cosmic web, a place where the universe's grand structure has failed. How does such a colossal emptiness come to be? The leading theory suggests it is not a single void, but the result of smaller voids merging over billions of years. Picture the foam in a sink after the water has drained away. Small bubbles of soapy film slowly coalesce into larger and larger empty pockets. In a similar way, gravity pulls matter into filaments and walls, leaving behind expanding bubbles of near-nothingness. The Boötes void could be the ultimate result of this process, a supervoid created by the merging of countless smaller voids. Another, more speculative idea involves dark energy, the mysterious force accelerating the universe's expansion. Perhaps in this specific region, dark energy acted with unusual strength in the ancient past, pushing matter apart more aggressively and preventing galaxies from ever forming. Now imagine you are at the helm of a starship crossing this abyss. For millions of years, you would see only an unbroken blackness outside your viewport. The familiar constellations of home would have long since faded into oblivion. The only points of light would be the faint, reddened glows of those few ancient galaxies, each one an isolated island in an ocean of void. A cosmic map of our local universe would reveal the Boötes void as a staggering spherical blank spot, a hole punched through the bright, filamentary web of galaxies. Animations of void formation would show this process in action, with the gravitational tug of war pulling matter into bright knots and strands, while the empty regions between them swell and merge into a single, terrifying emptiness. Artist concepts depict the view from within, showing a lone spiral galaxy adrift in the dark. Its nearest neighbor so far away would appear as nothing more than a dim, fuzzy star. The Boötes void is a monument to isolation, a chilling reminder that the cosmos is not just a place of brilliant light, but also of immense and silent shadow. While voids represent cosmic emptiness, other worlds are forged in a crucible of unimaginable heat and pressure. Orbiting a star 40 light-years away is a planet so bizarre it seems ripped from science fiction. Known as 55 Cancri, this exoplanet is a super-Earth, a world with about twice the diameter of our own but nearly 9 times its mass. This incredible density is the first clue to its strange nature. Scientists believe this world is not made of rock and iron like Earth, but is predominantly carbon. Under the intense conditions within the planet, A significant portion of this carbon has likely crystallized into a layer of diamond, creating a glittering mineralogical treasure beyond human comprehension. The environment on this world is a portrait of pure hostility. It is locked in a blisteringly tight orbit around its host star, so close that a single year, one complete trip, takes only 18 hours. From the surface, its star would appear gigantic, a raging furnace dominating the sky. This proximity results in surface temperatures soaring to around 4,900 degrees Fahrenheit, hot enough to melt iron and vaporize rock. The planet is likely tidally locked, meaning one side permanently faces the star in a perpetual incandescent day, while the other is a searing, eternal night. But how do we know what a world so far away is made of? The answer lies in the subtle art of spectroscopy. By analyzing the light from the parent star as it filters through the planet's atmosphere during transit, astronomers can detect the chemical fingerprints of different elements. In the case of 55 Cancri, the data strongly suggests an atmosphere rich in carbon-bearing gases like hydrogen, cyanide, and little to no water vapor or silicon-based dust. This points to a carbon-rich composition for the planet itself. Direct observation is, of course, impossible. We rely on complex models and the faint whispers of starlight to piece together the portrait of this alien landscape. Visualize an artist's depiction of this world. The surface would not be solid rock, but a churning global ocean of molten lava, glowing with a fierce reddish-orange light. Across this hellish expanse, vast continents of crystalline diamond might rise, glittering with a hard, cold fire under the light of an enormous, angry sun. The sky will be a perpetual sooty haze of carbon-rich gases. Animations of its orbit show the planet as a dark, compact sphere racing around its star in a frantic 18-hour dash, a cosmic bullet trapped in an eternal dance with a flame. This diamond planet is a stark reminder that the universe can craft worlds of astonishing and deadly beauty, realms where common elements become extraordinary under the most extreme of circumstances. A molten diamond world is a testament to cosmic extremes, but a moon with its own magnetic shield is a marvel of hidden complexity. Orbiting the giant planet Jupiter, Ganymede is not just another frozen satellite. It is a world that possesses a feature unique among all the moons in our solar system, its own intrinsic magnetic field. This makes Ganymede a miniature planet in its own right, with a dynamic, active interior that generates a protective magnetic bubble. This personal magnetic field, however, exists within the domain of a Titan. Jupiter's own magnetosphere is the largest structure in our solar system, a colossal, invisible fortress of charged particles that would engulf the Sun if it were visible. Ganymede's modest magnetic field is thus caught in a constant invisible tug-of-war with its parent planet's overwhelming power. This interaction sculpts a pair of spectacular, permanent auroral ovals around Ganymede's north and south poles. Unlike Earth's shimmering, transient northern lights, these are fixed features, glowing ribbons of light created as Jupiter's magnetic forces funnel charged particles directly onto Ganymede's atmospheric gases. The Hubble Space Telescope has clearly observed these glowing halos, providing visual proof of this unique celestial relationship. So, what does this tell us about the Moon's hidden depths? A global magnetic field is a signature of a churning, liquid interior. For a rocky body to generate such a field, it needs a core of electrically conductive material that is in motion. The leading model for Ganymede suggests a layered structure much like a cosmic onion, with a solid inner core of iron and nickel surrounded by a shell of molten metal, a convecting liquid iron core. This liquid metal dynamo, swirling and circulating over billions of years, is the engine that generates the Moon's magnetic heart. This discovery leads to an even more profound implication, the strong possibility of a vast subsurface ocean. Data from the Galileo spacecraft, which made close flybys in the 1990s, detected subtle perturbations in Ganymede's magnetic field that are best explained by the presence of a global saltwater ocean buried beneath a thick, icy crust. This hidden sea could contain more water than all of Earth's oceans combined, sloshing in the darkness between the rocky mantle and the icy surface. Visualizing this is key to understanding its wonder. Spacecraft imagery from Galileo and Juno reveals Ganymede's complex surface, a fractured landscape of light and dark terrain crisscrossed with grooves. Diagrams illustrating the magnetic interaction show Jupiter's immense magnetic lines, depicted in one color, pressing against and distorting Ganymede's smaller, independent magnetic field, shown in another. This clash creates the funnel-shaped cusps at the poles where the auroras ignite. Artist concepts take us beneath the ice, depicting a vast, dark ocean world, its waters illuminated by the faint, geothermal glow from the moon's rocky seafloor, a hidden abyss where the conditions for life, against all odds, might just exist. Ganymede is a world within a world, a moon with the soul of a planet, guarding its deepest secrets beneath a shell of ice and a shield of magnetism. Far from the frozen moon, a different kind of geometric wonder whirls around a gas giant. At Saturn's North Pole, a storm of impossible perfection rages. This is not a chaotic spiral or a simple circle, but a precise six-sided hexagon, a cloud pattern so vast and so stable it defies belief. Each side of this atmospheric polygon is longer than the entire diameter of our planet, and the whole structure has been spinning relentlessly for decades, a giant sigil etched into the clouds of a distant world. The Cassini spacecraft provided our first clear, breathtaking views of this phenomenon, revealing a honeycomb-shaped jet stream that contains a churning polar vortex at its very center. How can nature, which so often favors curves and chaos, produce a feature with such sharp, artificial-looking angles? The answer lies not in alien engineering, but in the complex physics of fluid dynamics. The leading theory suggests the hexagon is a standing wave pattern, a stable, self-reinforcing atmospheric oscillation. Imagine a fast-moving jet stream, a river of air, flowing around Saturn's North Pole. Differences in the speed of this river can create instabilities, much like the eddies that form when water flows around a rock in a stream. On Saturn, under very specific conditions of wind speed and planetary rotation, these instabilities can lock into a stable, polygonal shape instead of breaking apart into turbulence. It is a natural harmonic, a note held in the planet's atmosphere for years on end. Scientists have even recreated miniature versions of this hexagon in laboratory tanks of spinning fluid, proving that such geometric patterns can emerge from simple physical laws. Yet why is this feature so prominent and long-lasting on Saturn and seemingly nowhere else? The planet's deep atmosphere, its rapid rotation, and the specific nature of its polar winds all combine to create a unique environment where this six-sided wave can persist. Visuals from Cassini are nothing short of stunning, showing the hexagon in false color as a deep yellow band against the planet's softer, golden clouds, with the central vortex appearing as a deep, swirling blue eye. Animations of the polar vortex reveal a chaotic hurricane-like storm trapped within the geometric prison of the jet stream, a tempest inside a temple. The Saturn hexagon is a masterpiece of planetary meteorology, a reminder that the universe operates on a set of rules that can, under the right conditions, produce wonders of breathtaking order and beauty. Deep within the dusty heart of our own galaxy, a new class of ancient stars has been discovered, behaving less like steady beacons and more like cosmic retirees lighting up a pipe. Astronomers have named them the Old Smokers. These are red giants, stars in their final stages of life, located in the crowded central bulge of the Milky Way. For decades at a time, they can appear almost dormant, their light faint and steady. Then, without any clear warning, they exhale. They puff out colossal clouds of thick, dark dust, obscuring their own light and causing their brightness to plummet dramatically. It is as if a star is clearing its throat after a long silence, veiling itself in its own cosmic soot before eventually brightening once more. This slow, rhythmic cycle of dimming and brightening had gone unnoticed for so long because it happens on a human timescale, requiring years of patient observation to even detect. Time-lapse visuals of these stars would show a steady point of light gradually fading over many years, nearly winking out, before slowly returning to its original brilliance over another long stretch of time. The significance of this strange behavior goes far beyond mere stellar oddity. These old smokers are cosmic recyclers on a grand scale. During their dusty eruptions, they are belching out elements forged in their nuclear furnaces, including heavy elements like carbon, oxygen, and nitrogen. This process is a vital delivery mechanism, a way to seed the surrounding interstellar space with the very building blocks for new stars, planets, and even life itself. Without these ancient stars periodically enriching the galactic environment, the cosmic recipe for worlds like our own would be far poorer. infrared telescope images of the galactic center where these stars were found reveal a stunning, crowded vista, a place where normal observation is impossible due to obscuring dust clouds. It is in this hidden realm that the old smokers quietly perform their slow-motion dance, contributing to the chemical wealth of the galaxy, one puff at a time. They remind us that even in the death throes of stars, there is a purpose, a silent, rhythmic contribution to the ongoing story of the cosmos. Some stellar remnants do not drift quietly through the void. They flee. One such fugitive is a neutron star known as PSRB 2224+65, a cosmic cannonball hurtling through the galaxy at a speed that defies reason, over 2.5 million miles per hour. This incredible velocity is not a gentle cruise, it is a desperate sprint, and the star is literally plowing through the thin gas of interstellar space. The resistance it encounters creates a spectacular bow shock, a glowing wave of compressed and heated gas that arcs in front of it, much like the bow wave of a ship cutting through water. From our vantage point, this shockwave forms a long, slender neck and a wide, triangular body, a shape so distinctive that astronomers have nicknamed this entire structure the Great Nebula. It is a musical instrument sculpted from pure violence, playing a silent song as it speeds through the dark. How does a star, an object more massive than our sun, crushed into a sphere just a dozen miles across, achieve such an unbelievable speed? The answer lies in its violent birth. Neutron stars are the dense, collapsed cores left behind after a massive star explodes in a supernova. If that explosion is perfectly symmetrical, the newborn neutron star might get a gentle nudge. But nature is rarely so balanced. Most supernovae are profoundly asymmetric, with unimaginable blasts of neutrinos and ejected material erupting more powerfully from one side of the dying star than the other. Think of setting off a firecracker in your palm. If it explodes evenly, your hand might just feel a push, but if one side of the firecracker is much stronger, your hand will be violently kicked away. This is the supernova kick. A slight imbalance in the detonation of a stellar giant can act like a natural rocket engine, launching the resulting neutron star across the galaxy at a significant fraction of the speed of light. PSRB 2224+65 received one of the most powerful kicks ever measured. Visuals combining optical and X-ray observations reveal the full drama. The neutron star itself is a tiny, pinpoint source of intense X-rays, a beacon of pure density. Ahead of it, the Great Nebula glows in visible light, a ghostly blue wake that charts its path through the interstellar medium. Animations of the supernova kick are breathtaking, showing a massive star collapsing, then erupting in a lopsided fireball that blasts the newborn pulsar out of the wreckage like a bullet from a gun. Studying these runaway pulsars provides crucial forensic evidence for astrophysicists. By measuring their speeds and trajectories, scientists can work backwards to reconstruct the final moments of the supernova that created them. Each high-velocity pulsar is a cosmic fingerprint, telling a story of a star that did not die quietly, but exploded with a chaotic, universe-shaking fury that sent its heart racing into the unknown. While some stars are cosmic fugitives from stellar explosions, others are escape artists born from a galactic monster's grip. These are the hypervelocity stars, and they are moving so fast they are achieving the impossible, breaking free from the Milky Way's gravitational embrace forever. Their speeds are staggering, often exceeding 1 million miles per hour, a velocity so great that our galaxy's immense pull simply cannot hold them back. They're on a one-way trip into the cold intergalactic void. The origin of these stellar projectiles is one of the most dramatic stories in modern astronomy, and it centers on the most terrifying place in our galaxy, the supermassive black hole known as Sagittarius A star. The leading theory begins with a binary star system, two suns locked in a mutual orbit, wandering too close to this gravitational abyss. As the pair spirals inward, the black hole's tidal forces violently tear the system apart. It is a celestial game of gravitational tug-of-war with a single brutal outcome. One of the stars is captured by the black hole, doomed to orbit or be consumed, while its companion is slingshotted away, flung across the galaxy like a stone from a catapult. This process, known as the Hill's mechanism, imparts an incredible amount of energy to the ejected star, giving it the speed it needs to become galactic exile. Animations of this binary disruption process are both beautiful and terrifying, showing two stars dancing gracefully until they approach the black hole's event horizon. The invisible grip of gravity stretches and distorts their paths, pulling one star into a tight, fatal orbit while hurling the other away in a straight line at a significant fraction of the speed of light. These runaway stars are more than just cosmic curiosities. They are celestial messengers. By tracing their trajectories backwards across the sky, astronomers can map their paths directly to the galactic center. This provides invaluable, indirect insights into the chaotic environment surrounding Sagittarius A star, a region so obscured by dust that observing it directly is immensely challenging. Each hypervelocity star is a probe, its speed and trajectory telling a story about the black hole's mass and the gravitational forces at work in our galaxy's core. Maps that plot the flight of these stars show them as radiant lines of motion, all seemingly originating from a single dark point, a silent testament to the power lurking there. These stars are living proof of the violence that shapes our galaxy, a reminder that even in the vast, ordered rotation of the Milky Way, there exists a central engine capable of hurling suns into the infinite dark. While hypervelocity stars escape a visible monster, other cosmic giants are built from a substance we cannot see at all. Drifting through the Coma Cluster 300 million light-years away, there is a ghost, a galaxy known as Dragonfly 44. At first glance, it is a profound disappointment, a faint, wispy smudge of light that seems barely worth a second look. It possesses only about 1/100% of the stars found in our own brilliant Milky Way. Yet this dim apparition holds a staggering secret. When astronomers measured the motions of its sparse star clusters and lone, wandering suns, they found them hurtling along at impossible speeds. The gravity required to hold these stars within the galaxy to prevent them from simply flying off into the void was immense. The calculations revealed a truth that defies intuition. Dragonfly 44 has roughly the same total mass as our entire Milky Way galaxy. This means that 99.99% of its substance, the overwhelming bulk of its being, must be dark matter. It is a cosmic phantom, a galaxy-sized halo of invisible mass that has somehow gathered a few lonely stars as an afterthought. How does such a massive structure form with almost no visible matter to show for it? This is the central puzzle of Dragonfly 44. Current theories of galaxy formation suggest that dark matter acts as a gravitational scaffold, a framework upon which ordinary gas and dust can collect and eventually collapse into stars. But here that process seems to have failed almost completely. Perhaps the environment within the dense Coma Cluster played a role, with fierce galactic winds or intense radiation from neighboring galaxies stripping away the raw gas before it could form many stars, leaving behind a pure skeleton of dark matter. Or it might be a failed galaxy, one that was born with a strange primordial deficiency of the gas needed for star formation, a cosmic stillbirth that never ignited. Visuals comparing Dragonfly 44 to the Milky Way are jarring. One image shows our galaxy as a radiant, star-filled spiral, a brilliant pinwheel of light. The other reveals only a faint, diffuse glow, a barely there haze where a giant should be. The most telling graphic is an illustration of the dark matter halo. It would show the same vast, invisible sphere enveloping both galaxies, but for the Milky Way, that sphere is filled with a glittering disk of stars. For Dragonfly 44, the same immense halo is almost completely empty, containing just a handful of tiny, isolated points of light adrift in an ocean of dark. This ghostly galaxy forces us to confront the true nature of our universe. Dark matter is not just a minor component, it is the dominant architect of cosmic structure. In places like Dragonfly 44, we see the universe for what it mostly is, a realm of shadow and mystery, where the invisible framework is the real substance and the stars are merely fleeting decorations. The enigma of Tabby's star deepens when you look beyond the erratic flickering. A painstaking analysis of historical data has revealed an even more baffling long-term trend. Astronomers delved into a unique archive, a collection of old photographic plates from the Harvard College Observatory that captured the sky for over a century. When they meticulously measured the star's brightness on these fragile glass plates, they uncovered a pattern that defies any simple stellar behavior. Cosy 8462-852 has been steadily dimming for the last 100 years, The total drop is a staggering 15%, a slow, relentless fade that is completely unprecedented for a star of its type. This is not the chaotic, day-to-day dimming that first caught our attention. This is a century-long slide into darkness. Explaining this with a swarm of comets or a circumstellar disk becomes incredibly difficult. No known natural phenomenon can easily account for such a sustained, massive loss of light over such a vast timescale. The scientific community has responded with a global vigil. Observatories around the world, from the Las Cumbres Observatory Global Telescope Network to dedicated amateur astronomers, now keep a constant watch on this stellar oddity. The latest data continues to show unpredictable dips superimposed on that long, slow decline. Graphs plotting this century of observation are startling. They show a mostly flat line for other similar stars, but for Tabby's star, the line slopes decisively and inexorably downward. It is a visual record of a mystery unfolding in slow motion. The astronomers leading this research speak of a puzzle that challenges the very frameworks of stellar astrophysics. They are exploring every possibility, from an immense warped ring of dust and planetary debris to the slow gravitational accumulation of a vast cloud of material from the interstellar medium. The alien megastructure hypothesis, while not the favorite explanation, remains on the table simply because it is one of the few ideas that could, in theory, explain both the short-term, jagged dips and the long-term, secular dimming. It proposes a structure under construction, slowly blocking more and more starlight over generations. This star forces us to confront the possibility that we are witnessing a new, unclassified phase of stellar evolution, or a celestial process we have never before imagined. The long fade of Tabby's star is a mystery written in light, a cosmic signal we're only just beginning to decode. A ghost passed through the Earth in September of 2017. It was not a specter of myth, but a subatomic wraith, a neutrino of almost unimaginable energy, born in a cataclysm billions of light years away. It pierced our planet, encountering almost nothing, and continued into the Antarctic ice. There, deep below the surface, it met its end inside a cubic kilometer of pristine ice, a detector so vast it is called the Ice Cube Observatory. For the first time in history, we did not just detect such a ghost, we traced its path back to its monstrous source. This single event marked the dawn of an entirely new way to see the universe, neutrino astronomy. Neutrinos are the universe's most elusive particles. They are cosmic phantoms, so insubstantial that trillions pass through your body every second without a single interaction. They are produced in nuclear reactions, from the sun's core to the most violent explosions in the cosmos. Catching one is difficult, but catching one and knowing where it came from is a feat that once seemed impossible. The key was a flash of blue light. When the neutrino slammed into an atomic nucleus in the ice, it created a secondary particle that traveled faster than light could travel through that same ice. This produced a shockwave of radiation, a blue glow known as Cherenkov radiation. An array of over 5,000 sensitive light sensors, frozen into the ice like a giant three-dimensional grid, recorded the direction and the energy of this telltale flash. The data pointed like a compass needle back to a specific patch of sky. The world's telescopes swiveled to look. There in the constellation Orion, they found a blazar, a galaxy named TXS0506 plus 056. A blazar is one of the most energetic phenomena in the universe. It is a galaxy with a supermassive black hole at its heart, but unlike our own quiet Sagittarius A star, this black hole is a voracious, active engine. As it devours matter, it fires twin jets of radiation and particles directly into space at nearly the speed of light. We on Earth happen to be looking directly down the barrel of one of these jets, making its violent light appear impossibly bright. This blazar was in a state of extreme eruption at that exact moment. The high-energy neutrino was a direct messenger from this particle accelerator on a galactic scale. This was the landmark discovery. For over a century, scientists had wondered about the origin of cosmic rays, high-energy atomic nuclei that constantly rain down on Earth. Their paths are bent by magnetic fields obscuring their origins, but neutrinos, having no charge, travel in perfectly straight lines. This single ghost particle provided the first concrete evidence that blazars are one of the primary sources of these mysterious cosmic rays. It was a definitive link between a cosmic accelerator and the particles it hurls across the universe. Visualize the journey of this neutrino. animations would show it being born in the relativistic jet of the blazar, a tiny speck of pure energy flung into the void. It would travel for billions of years, crossing intergalactic space before finally reaching Earth and plunging into the ice. Imagery of the ice cube detector reveals its astonishing scale, a network of sensors buried over a mile deep, turning a continent of ice into the world's largest and most unlikely scientific instrument. And finally, telescopic views of the blazar itself, a brilliant churning point of light, the cosmic cannon that fired a ghostly bullet, and in doing so, opened a new window onto the violent universe. The ghostly neutrino revealed a single cosmic particle accelerator, but some structures in the universe act as entire factories for discovery. Far across the cosmos, at a distance of 7 billion light-years, lies a galaxy cluster of such immense proportions it has earned the nickname El Gordo, the Fat One. Officially catalogued as SDCLJ 0102-4915, this colossal gathering of hundreds of galaxies is the most massive cluster known in the early universe, a true giant from a time when the cosmos was only half its current age. Its existence alone pushes the limits of our cosmological models, challenging our understanding of how such gigantic structures could assemble so quickly after the Big Bang. But its true wonder lies not just in its sheer bulk, but in what its gravity does to the fabric of space around it. El Gordo is so massive that its gravitational pull warps the very space it occupies, creating a natural magnifying glass of cosmic proportions. This phenomenon is called gravitational lensing. The cluster's immense gravity bends the path of light from galaxies that lie far behind it, much like a glass lens bends light in a telescope. This warping does two extraordinary things. It distorts the images of those background galaxies, stretching them into long, faint arcs of light, and it magnifies them, making these incredibly distant, faint objects bright enough for us to see. Without this natural telescope, these galaxies would be far too dim for even our most powerful observatories to detect. Hubble's Space Telescope images of El Gordo are nothing short of breathtaking. They show the cluster's own galaxies as brilliant points of yellow and white, but surrounding them are those telltale blue streaks and smears, the distorted and magnified light from galaxies that existed when the universe was even younger. These graceful arcs are the signatures of warped spacetime, a visual confirmation of Einstein's theory of general relativity painted across the sky. By meticulously mapping the shapes and positions of these lensed arcs, astronomers can create a map of the cluster's total mass, including the vast halo of dark matter that provides most of its gravitational glue. This is how we know El Gordo is not just big, but truly fat, weighing in at a staggering 3 million billion times the mass of our Sun. Studying colossal clusters like this is vital for cosmologists. They serve as extreme laboratories for testing our models of the universe's composition and evolution. The sheer number of these clusters, their masses, and their distribution across time tell us about the interplay between dark matter, which pulls structures together, and dark energy, which pushes them apart. Does El Gordo's existence so early in cosmic history mean our models need adjustment? Does the way its mass is distributed match what computer simulations predict? Every arc of light, every map of its invisible dark matter halo provides another piece of the puzzle, helping us understand the fundamental forces that have shaped everything we see. This distant giant is more than a curiosity, it is a cosmic scale, weighing the contents of the universe and testing the very laws of physics. The cosmos has a rhythm, a heartbeat you can hear if you know how to listen. Far away in the large Magellanic Cloud, a satellite galaxy of our own, a star system designated Macho 80.744 3.1718 pulses with a powerful, regular beat. This is not the simple, predictable dimming of one star passing in front of another. This is a stellar heart, throbbing with the violence of an intimate and destructive dance. At its core are two stars locked in a breathtakingly tight orbit, circling each other so closely that a full year passes in just a little over a day. Their proximity creates a gravitational embrace of unimaginable force. As they whirl around each other, each star's gravity pulls on the other, stretching them both out of their perfect spherical shapes. They become slightly egg-shaped, bulging toward one another in a permanent strained kiss. This constant tidal pulling and squeezing creates immense friction and pressure within the stars themselves, heating their interiors to a fever pitch. The result is a periodic seismic shudder, At the point of closest approach in their orbit, the tidal forces reach a crescendo, triggering massive outbursts. The stars do not just brighten, they erupt, their luminosity surging in a sharp, spectacular spike before slowly fading away until the next orbital embrace. The light curve from this system, a graph of its brightness over time, looks nothing like a typical eclipsing binary. Instead, it shows a precise, rhythmic pattern, a steep peak and a gradual decline that repeats with the exact timing of the orbital period, a literal heartbeat written in starlight. Imagine an animation of this celestial tango. Two brilliant stars, one larger and one smaller, whirl around a common center of gravity. As they draw near, their surfaces roil and distort, pulled into egg-like shapes by the mutual gravity. At the moment of their closest pass, a wave of energy erupts across their surfaces, a flash of intense light that represents the peak of the heartbeat. The light curve graph beside it would plot this brilliant flash, the line on the chart leaping upward in a sharp, narrow spike before trailing off in a long, gentle decline, only to leap again with the next orbital cycle. These heartbeat stars are more than just beautiful oddities. They are extreme natural laboratories. They allow astronomers to study tidal forces and mass transfer at their most intense. The gravitational tug-of-war is so powerful that it can strip material from one star and dump it onto the other, a slow cosmic transfusion that will ultimately change the fate of both. Watching this system is like watching a stellar relationship in fast forward, a dance of attraction and consumption that plays out over millions of years. Each precise beat is a reminder of the invisible forces that bind the universe together, a rhythm of creation and destruction echoing in the dark. Far from the intense gravitational pulse of a heartbeat star, other worlds defy expectations with their impossible lightness. Orbiting a sun-like star over 200 light-years away, a class of planets exists that are so fluffy they have been nicknamed super puffs. These are not small, rocky worlds like Earth, nor are they dense gas giants like Jupiter. They are colossal balloons with sizes comparable to Jupiter, but with masses a mere fraction of our solar system's giant. This combination of immense size and minuscule weight gives them a density astonishingly similar to cotton candy. A planet like Kepler-51b is a perfect example, a world you could theoretically hold in your hand if you had a hand large enough to grasp a sphere wider than Jupiter. The central mystery is what holds these vast, tenuous spheres together. How can something so large have so little substance? The answer lies in their atmospheres. A superpuff is not a solid ball with a thin layer of air, it is almost entirely atmosphere. These planets are believed to have enormously extended, bloated envelopes of hydrogen and helium that stretch tens of thousands of miles into space, making them appear like gigantic, wispy clouds from a distance. The prevailing theory to explain this bizarre inflation suggests these worlds are in a state of dramatic transition. They may be orbiting dangerously close to their parent stars, whose intense heat is cooking them from the outside in. This stellar radiation is pumping so much energy into their upper atmospheres that the gases are literally boiling away into space, creating a puffed-up, extended halo as the planet actively loses mass. It is a slow-motion disintegration, a cosmic sigh that stretches the planet's atmosphere to its breaking point. Another compelling idea posits that these planets formed much farther out in their solar systems, in the cold, dark reaches where ices and light gases are plentiful. They may have migrated inward later, but they carried with them the incredibly thick primordial atmospheres they accumulated in their youth. Artists' concepts bring these bizarre worlds to life, showing them not as defined orbs, but as hazy, softly glowing spheres of pastel color, their outer layers so tenuous they almost merge with the blackness of space. You might see a bloated, peach-colored world hanging in the sky, its atmosphere so extended that its star would appear as a blurred, dim smudge from the surface, if a surface even exists beneath the incredible depth of gas. Diagrams comparing planetary densities are starkly revealing. They would place a dense, metallic world like Mercury on one end, a gas giant like Jupiter in the middle, and the superpuff planets way off on the other extreme, their density bar barely registering above zero. The existence of these cotton candy worlds forces a complete rethinking of planetary formation and evolution. They represent an extreme pathway that our own solar system never took, proving that the universe can fashion planets from a recipe we are only beginning to understand. A cosmic trailblazer is carving a path of creation through the void. Astronomers have spotted a supermassive black hole, a behemoth with the mass of 20 million suns, hurtling away from its home galaxy at a speed that defies belief. It is not traveling alone, nor is it moving in silence. Stretching for 200,000 light years behind it is a brilliant, narrow bridge of young blue stars, a stellar contrail left in the wake of this impossible escape. This is not the dark, consuming force we typically imagine. This is a runaway engine of birth, a paradox racing through the cosmos. The question is, what cosmic catastrophe could have launched such a monstrous object into the intergalactic wilderness? The answer lies in a gravitational waltz of unimaginable violence. The leading theory begins with a galactic merger, a slow-motion collision of three galaxies, each with its own supermassive black hole at its core. As the galaxies intertwined, their central black holes began a complex dance, spiraling inward toward a common center. Two of the black holes, drawn ever closer, eventually merged in a cataclysmic event that sent a powerful burst of gravitational waves rippling through space-time. This explosion of energy was not perfectly symmetrical. The theory suggests that the third black hole acted as a gravitational slingshot, absorbing the directional kick from the merging pair. In a flash, it was ejected from the galactic core like a stone from a sling, catapulted out into the empty space between galaxies at a speed of over 5 million miles per hour. The incredible trail of stars it left behind tells the second part of this story. As the black hole plowed through the dense gas surrounding its former home, it did not devour it. Instead, the immense shock and compression from its passage triggered a frenzy of star formation. Think of a ship moving through a still sea, its wake churning up foam and life. In the same way, this black hole's violent motion churned the primordial gas, compressing it into dense, hot knots that ignited into the brilliant blue stars we now see marking its path. This observation is more than just a spectacular sight. It is direct evidence of the chaotic dynamics that govern the hearts of galaxies. It confirms that supermassive black holes can indeed be ejected from their homes, a prediction of Einstein's theories that had never been so clearly observed. Dramatic animations of this event would show the three black holes in a frantic spiral, the merger of two creating a visible shockwave that violently expels the third. The Hubble Space Telescope imagery of the actual star trail is breathtaking, a long, thin, almost delicate line of blue light against the dark backdrop of space, a permanent scar of a cosmic battle that occurred millions of years ago. This runaway giant shows us that even the universe's most destructive forces can, under the right conditions, become unexpected artists, painting a line of new suns across the canvas of the dark. The afterglow of the Big Bang itself holds a cosmic bruise. This is the cosmic microwave background, the oldest light in the universe, a nearly uniform curtain of microwave radiation that permeates all of space. Yet within this fossilized echo of creation, there exists a vast and profound anomaly known simply as the cold spot. It is an immense region of space, billions of light years across, that is significantly colder than its surroundings, a chill that standard models of cosmology struggle to explain. This is not a minor fluctuation. The statistical significance of this cold spot means its existence is highly unlikely to be a random quirk. It is a real feature, a cosmic puzzle etched into the very fabric of the infant universe. The primary, more conservative explanation points to a supervoid. This theory suggests that in the direction of the cold spot lies an unimaginably large and mostly empty region of space, a cosmic desert so vast that its gravitational influence could cause the observed temperature drop. As light from the cosmic microwave background travels through such a void, it must climb out of a gravitational well, losing energy and thus shifting to a colder temperature in a process known as the integrated Sachs-Wolf effect. However, there is a problem. Surveys searching for this proposed supervoid have found emptiness, but not nearly on the scale required to account for the profound cold. The void we have found is large, but the cold spot is immeasurably larger, creating a mismatch that leaves the mystery wide open. This failure of the simple void explanation has given rise to one of the most exotic ideas in all of cosmology. The cold spot could be evidence of a collision with another universe. In the multiverse hypothesis, our universe is just one bubble in a vast, frothing cosmic foam of other universes. If in its earliest moments our inflating universe bumped into a neighboring bubble of reality, The energy of that collision could have left a permanent scar, a colder patch on the sky exactly like the one we observe. This idea is as breathtaking as it is radical, suggesting we might have tangible evidence of a cosmos beyond our own. Maps of the cosmic microwave background are essential to visualizing this. They portray the entire sky as an oval, with the cold spot appearing as a distinct, large, and deep blue patch against the warmer reds and yellows of the rest of the universe. To illustrate the supervoid hypothesis, visualizations might show a vast spherical emptiness in space, with the ancient light from the Big Bang stretching and cooling as it passes through this region. For the multiverse collision, animations could depict our universe as a bubble suddenly jostled by an impact from another invisible bubble, creating a permanent ripple of cold in its SIMB. This cosmic chill forces us to confront the ultimate frontiers of physics, a place where the line between established science and profound speculation beautifully blurs. The dream of finding a signal from our cosmic backyard almost became a reality in 2020. A team of scientists using the iconic Parkes Radio Telescope in Australia detected a tantalizing narrowband radio signal, a clean, sharp tone that seemed to originate from the direction of Proxima Centauri. This is not just any star, it is our sun's closest neighbor, a red dwarf located a mere 4.2 light years away, and it is known to host at least one planet within its habitable zone. The signal, named BLC-1, was everything astronomers had been hoping for. It was a single, pure frequency, the kind of signature an artificial transmitter would produce, and it appeared to drift in frequency exactly as you would expect from a signal originating on a planet orbiting a distant star. For a brief, electrifying moment, it felt like the discovery of the millennium. The global response was immediate and feverish. Headlines around the world buzzed with the possibility that we had finally made contact. But science is a process of ruthless verification, not instant celebration. The team behind the discovery did not announce a finding, they announced an anomaly that required painstaking investigation. They followed the strict protocols of modern SETI, the search for extraterrestrial intelligence, re-observing the star for months, scanning for a repeat of the signal that never came. They analyzed the signal's properties with excruciating detail, looking for any telltale sign of a terrestrial origin. The ultimate conclusion was a lesson in cosmic humility. The signal was almost certainly human-made radio interference, a product of our own technology. The most likely culprit was a malfunctioning electronic device somewhere on Earth, its faint radio emission reflecting off a passing satellite or piece of space debris and creating the illusion of an extraterrestrial broadcast. Visuals of the Parkes telescope, a giant white dish set against the Australian outback, symbolize this monumental effort. Diagrams of the Proxima Centauri system show its small, dim star and the known exoplanet, Proxima Centauri b, a world that might have conditions for liquid water. The story of BLC-1 is not a story of failure, but a masterclass in scientific rigor. It exemplifies the immense challenge of SETI, sifting a genuine cosmic hello from the ever-growing cacophony of our own civilization. It proves that our methods of verification are working, that we are becoming better and more disciplined listeners. The silence that followed was not a disappointment, but a clearing of the static, allowing us to continue the search with sharper ears and a renewed sense of purpose, forever listening for a signal that is not just strange, but truly from the stars. From fleeting signals to ancient giants, these 25 objects reveal a universe far stranger than fiction. We have encountered stars that dim unpredictably, worlds made of diamond, and galaxies built from invisible matter. We have traced the paths of runaway stars and witnessed the perfect geometry of dying suns. Each one of these cosmic oddities, from the WOW signal to the Great Attractor, pushes at the boundaries of our understanding, forcing us to question the very laws of physics and our place in the grand scheme. These are not merely curiosities, they are the engines of scientific progress. Every mystery, every anomaly that does not fit our models is an invitation to look deeper, to think bigger, and to develop new tools to probe the darkness. They remind us that the universe is under no obligation to make sense to us, and that humility in the face of such wonder is our greatest strength. Our journey through the cosmos has just begun, and the greatest discoveries undoubtedly lie ahead, waiting in the vast, silent dark for the next curious mind to find them. We want to hear from you. Of all these bizarre wonders, which one captured your imagination the most? Was it the silent tumbling of Oumuamua, the perfect ring of Hoag's object, or the ghostly pull of the Great Attractor? Let us know in the comments below which object you found the strangest, and subscribe to join us on our next exploration into the deepest mysteries of space. Our search for the strange is accelerating, powered by a new generation of eyes on the cosmos. The James Webb Space Telescope, with its infrared gaze, peers through cosmic dust to witness the birth of the first stars and galaxies, potentially revealing objects from the dawn of time that defy all classification. Soon the Vera C. Rubin Observatory will begin a relentless, decade-long movie of the night sky, scanning the entire visible heavens every few nights. It will not just find more of what we know, it will find the things we have never thought to look for, the anomalies that blink into existence and vanish before we can even name them. This flood of data is so immense that no single team of scientists could ever hope to sift through it all. This is where the search becomes a truly human endeavor. Citizen science projects invite anyone with curiosity to help scan these celestial images, to be the first to spot a flicker that does not belong. Artificial intelligence algorithms work alongside them, trained to recognize patterns invisible to the human eye, flagging the subtle oddities in a sea of stars. The next great cosmic mystery might not be found in a university lab, but on the laptop of a student or the tablet of a retiree gazing at the sky from their backyard. The universe has shown us its capacity for the bizarre, and our tools for listening and looking are now more powerful than ever. The next chapter of discovery is being written, and the strangest object of all might be waiting for its moment to reveal itself, perhaps to you.